Today we're going to be talking about simplifying rational expressions. And remember, a rational expression is something where you have a fraction. That's all a rational expression is. So, state the excluded values for each expression. So, an excluded value is something that makes the denominator, otherwise known as the bottom, equals 0. So what I do is I state the bottom equal to 0, b equals -7. So really what you're saying here is b cannot be equal to -7. So that's what you're really doing. So a squared minus a minus 12. I solve this equation. Oh, look, it's a quadratic, so I have to factor two things that multiply to be -12 but add to be a -1, minus 4 plus 3. Okay, so then a equals -4. I'm sorry, a equals a positive 4. And a -3. What I did is I set a minus 4 equal to 0. And I set a plus 3 equal to 0. Now, again, it's a cannot be those things. Excluded values. So this is a rational function. And I didn't do this section. This is for summer school. I didn't do this section. But that's a rational function, and we could graph that if we wanted. But the excluded value, again, is what makes my denominator equal to 0. So x cannot be equal to -1/2. Okay, simplifying rational expression. Let a and b be polynomials. So what we do is we factor, and once you have a common factor on the top and bottom, we can cancel. So for this first example here, what we do with this top is we factor out the x minus 3. With the bottom, again, we factor out the 4, which gets us x minus 3. Those cancel, and that simplifies to 3/4. Notice what they didn't do. They didn't just cancel the x's. They didn't cancel the 9 and the 12. That's not going to work for you. Okay, what you have to do is you have to get factors. You have to get two things that are multiplied together. Okay, so simplifying the following here. And really, you've done this before when you were simplifying exponents, quite honestly. Okay, so 32 divided by 4, well, that's 8. So I've left over an 8 on top. X to the 5th over x to the 1st, one of those x's cancels and makes that an x to the 4th. The y squared over y to the 7th. Looking at this another way, it's like saying y times y on the top, and then y to the 7th. I wrote out 7 of those. 2 of those cancel. How many am I left with? I'm left with 5 of those y's in the denominator. Okay, simplify the following. Again, you have to factor everything. Everything has to factor. So I factor out a GCF on the top. So if I factor out a 4 on the top, I'm left with an x plus 4 on the bottom. Now we have to think of things that multiply to be a -36 and add to be a positive 5. But one of the things that my teacher said when I was learning this in high school is they said, look for something that you might have a factor on the top. Okay, I have an x plus 4 on the top. Maybe x plus 4 is a factor on the bottom. So I think to myself, okay, what times 4 equals 36? Well, 9. So -9 plus 4, let's see. Does that work? Yes, that gets me the correct middle term because -9 plus 4 is a -5, and -9 times 4 is 36. Those cancel, so I'm left with 4 over x minus 9. Now my excluded values, glad I remembered to do this. This is complicated because first, whatever makes this denominator 0, so that's going to be 9, plus also what you canceled out. You can't forget about what you canceled out. So x cannot be equal to 9 and negative 4, okay? So don't forget what you've, I actually was writing that correctly, wasn't I? And I think I spelled canceled wrong. Don't forget what you've canceled out, okay? Okay, simplifying this expression. I do this a little differently than the book. I do this differently because I'm a rebel. Okay, I always like my x squared term to be positive. So I'm going to factor out a negative 1 that changes the sign of everything. On the bottom, GCF factor out an 8. Now continue factoring. On the top, I have a difference of 2 squares. So that factors to x minus 5, x plus 5 over 8 times x minus 5. Now, the x minus 5's cancel. So I basically have a negative x plus 5 over 8. And again, I do this a little differently from the book. If you distribute through that negative, I think that's what they have as your answer in the book. I prefer my method. I just think it's easier for my students to understand. Okay. Oh, I didn't state my excluded values. Oh, I knew I would forget. Okay, so stating my excluded values, whatever at the very beginning before I canceled. So x cannot be equal to 5. Okay, simplifying the following. I'm going to highlight that state the excluded values so that hopefully I remember to do it. So now, again, it's just more factoring, okay? That's why we did so much factoring. So, two things that multiply to be a negative 35, but add to be a positive, negative 2. So, negative 7 times a positive 5, that adds to be a negative 2, multiplies to be a negative 35. Okay, 14. Oh, I have a negative, but then a positive, so both need to be negative. Again, look for a factor, okay? 5 doesn't go into 14, but I know 7 does. 7 times 2, negative 7 times negative 2 equals a positive 14. Negative 7 plus a negative 2 is a negative 9. So my x minus 7's cancel. So this simplifies to x plus 5 over x minus 2. Don't forget your excluded values, okay? Right there, 2 is what makes that denominator equal 0. Don't forget about the one that you canceled. 7 is also an answer. Okay? Common mistake that I often see is sometimes I see students want to cancel that and they leave it as 5 over negative 2. That's not correct. Remember, you can only cancel under multiplication if they're a factor. Okay? Thanks for watching my video on simplifying rational expressions.